So I'm going to start officially my today's session on hypothesis testing. And as you can see that I have taken some time to write the question on the screen so that you can copy it, you can get time to copy the question. Meanwhile, I'm asking all the students to write their roll numbers in the chat box because I'm going to disable the chat box. Okay, so I'm going to discuss this particular problem. And the problem which is there in front of you is nothing new. Probably you have guessed already that this particular problem is falling under the section of test of significance of two population proportions. Question is, why am I going to discuss this particular issue once again? It is because, let me write the case which I'm going to study over here. It is test of difference of proportion of population. So this is the case which have already been discussed by you, by us, and you very well know the statistical tool that we use actually is given by the following formula: small p1 minus small p2 minus capital P1 minus capital P2 by root over P cap Q cap 1 by N1 plus 1 by N2. Okay, now today I'm going to discuss this particular problem from the viewpoint of p-value approach. I'm going to talk about a new topic which is called p-value, and this is often used, and it is often used and is very useful in dealing with hypothesis testing problem. Question is, why do we need this p-value, and why is this p-value is important? When we deal with hypothesis testing, we first set up the null hypothesis. We know that very well. And this null hypothesis either is accepted or is rejected. These are the two things that we can consider after the calculation is done. Either we are going to accept our null hypothesis or we are going to reject our null hypothesis. And one another case which can happen, and that is also kind of a binary system, where the assumption that you have made according to the population or with respect to the population, this H0 is basically true, your assumption was basically true, or the assumption regarding the population is false. Now under this situation, we are going to accept the null hypothesis or you are going to reject the null hypothesis. Now when we accept the null hypothesis under the condition that originally the assumption made on the population is true, this is all right. We do not have any problem about this. It is not an error. So no error has been made. Null hypothesis was true and we have accepted it. When we reject null hypothesis, where the null hypothesis about the population was false, that is also not an error. But error is made when these cases happen. So when we reject the null hypothesis, while the null hypothesis was originally true, then actually we have made some kind of error. And here, if we accept a false null hypothesis, then that becomes an error. So there are two types of errors that can be made in a hypothesis testing problem. These two errors have got two different names. This is called a type 1 error, and this is called type 2 error. Today I'm going to discuss about type 1 error. Why? Because when a statistician deals with a particular hypothesis testing problem and he wants to give some sort of conclusion, regarding the population, then he is always prone to make type 1 or type 2 error with some probability. And therefore, we need to know with what probability he has made this type 1 error. That becomes very important in a statistical hypothesis problem. Okay, so this probability of type 1 error basically means what? Probability of rejection of null hypothesis H0, given that H0 is true. This probability we need to calculate, and we often denote this probability by the symbol alpha. And you will glad to know that this alpha, this probability of committing the type 1 error, is actually known as level of significance, which we fix before we start solving the problem. So we fix our level of significance. Now fixing of level of significance is done in various ways. Some people fixing of level of significance. Some people fix the level of significance at 5%. Some people like to fix the level of significance at 1%. If I fix the level of significance at 5%, we consider alpha equal to 0.05. If we want to fix the level of significance at 1%, we consider alpha to be 0.01. If we fix the level of significance at 10%, we consider 0.10, and so on. Sometimes some people fix the level of significance at 50%. So they consider 0.50. And there are various level of significances are present. Various sort of level of significances are present. Now, which level of significance must we consider? That becomes a very important issue for all of us. I'm trying to justifying my decision on the basis of the sample about the population based upon some predefined notion of the level of significance. The others may not agree on that issue. They may ask me, why have you considered 5% level of significance and why not 1% level of significance? Because in yesterday's class, we have seen that there might be some problems which can be rejected in 5% level of significance while accepted in 1% level of significance. So this becomes an issue to know what level of significance must we consider. That is one part. Second problem arises from the technicality of the normal curve and the level of significance. That technicality I must discuss first of all. Suppose this is my standard normal curve, okay, and suppose I'm fixing my point 1.96 over here and minus 1.96 over there, and you know that in this particular range, the probability that Z will lie is actually 0.95. We have already discussed it. Now, suppose you are solving a problem, and while solving the problem, you have got the Z to be 1.97. Suppose your Z value has come out to be 1.97, which is your Z1. Now 1.97 is very close to this point 1.96. Suppose this is my 1.97. And you have reached to this particular conclusion on the basis of some sample of some size. So this particular value is dependent upon the sample size that you have considered. Okay, so you are in a position of to have some doubt in your mind that my value is too close to the boundary line. Here I am going to reject the null hypothesis. If 1.97 is definitely 1.97 is greater than 1.96, and you are going to reject your null hypothesis at 5% level of significance at alpha equal to 0.05. Okay, now after rejection, you are just scratching your head and you are thinking that have I done anything wrong? Is there any mistake in my sample size? If no questions come in your mind, that is a different issue, but the questions may come to your mind. This sort of questions may come to your mind. It is happening because you already know that there are two sorts of region in this type of problem. One region is called the acceptance region, another region is called the rejection region. Suppose this is my acceptance region. I am denoting this by minus z alpha to plus z alpha. Okay, this is my acceptance region. And suppose this is my rejection region. Now, what is happening over here, if you carefully observe, that this point z alpha or this point minus z alpha, these become the boundary points. Okay, and these boundary points, rejection region is sometimes also called critical region, critical or rejection region. These boundary points that we are getting over here, these are called the critical values. These boundary values are called the critical values. And when you are solving a particular problem, your values, say Z 1.97, is actually falling very near to the critical value. The critical value is 1.96. Then you are thinking that, shall I repeat my experiment once again with a different sample, with a different size, and setting the null hypothesis as before? Will it give me some sort of value where I can see that the null hypothesis is being accepted? Or is this rejection is my error, or is this rejection is bound to happen? That becomes a problem with all of us when we do the statistical hypothesis problem. To eliminate this kind of doubt from mind, what statisticians often do is that they go for the p-value approach. And to apply p-value, we have to know, so what is the meaning of that? What is the definition of that p-value? So the p-value, first of all, has to be defined, and then I'm going to explain what the p-value is. The definition of p-value is given as follows. The p-value is the smallest level of significance. The p-value is the smallest level of significance. P-value is the smallest level of significance that would lead to rejection of, that would lead to rejection of the null hypothesis H naught H naught with the given data. With the given data. First of all, you will get to see that this p-value, this new term that I'm actually applying over here, this p-value is nothing but a kind of level of significance. It is also a kind of probability with which we reject our null hypothesis when the null hypothesis is true. So p-value is also a kind of level of significance. Suppose, but it is not just a level of significance. It is the level of significance which is the smallest one. So suppose my p-value is alpha. I'm getting my p-value to be alpha. Okay. Now, according to the definition, it says that at alpha level of significance, H naught will be rejected, isn't it? So if we consider any value greater than alpha, like alpha plus 1, alpha plus 2, and so on, alpha plus k, at all of these level of significances, the null hypothesis H naught will be rejected. It is quite obvious. So if I consider the set consisting of all these level of significances like this, we know that at all of these level of significances, the null hypothesis will be rejected. And this is the lowest member of the sequence. This lowest member is actually known as p-value. So we have got some lowest value of the level of significance at which the null hypothesis will be rejected. But if you choose any, but if we choose any level of significance which is lesser than alpha, then that alpha 1 will lead to acceptance of H naught. So once we know this kind of lowest value, our doubt will be cleared and we are free to choose our level of significance. At least we can say at what level of significances this this hypothesis, this null hypothesis that we have set is going to be rejected. Okay, so I'm going to apply this particular strategy in the problem which is given in the previous page. But second point is that here I have explained why do we need the p-value. This is the why part. Why and what part. What is p-value and why it is needed. Thirdly, I want to explain how to calculate the p-value, because you have to know there must be some formula which will help you to calculate the p-value. Okay, so it has got 3 different formula, and it depends upon the number of tests, the type of test that you are actually using. Suppose case 1 is that you are actually dealing with a two-tailed test. Suppose your test is two-tailed. Then in this case, the p-value formula is given as twice 1 minus phi of z naught. I'm going to explain what phi z is and what z naught is. This is the formula for two-tailed test. Case 2, if you are considering one-tailed test, and in this one-tailed test, you are actually interested in right tail of the normal curve, then your p-value is calculated as 1 minus phi of z0. And the last case is case 3. One-tailed test is being considered and you are interested in left tail, then the p-value is actually calculated by phi of z naught. Okay. Now, all this formula that you have to keep in mind. And if you want to know what phi z naught is, just take a screenshot of this page. I'm moving on to the next page. Z naught is the value which is or which has been obtained by calculating the appropriate test statistic, the appropriate test statistic, and the function phi z is nothing but a notation for the function that the random variable capital Z is less than or equal to small z. So that is your phi z. Okay, so with this knowledge of phi z, and we can have the knowledge from the normal table that I have provided you in the class note 8, we can calculate the p-value, which is the lowest level of significance, and that p-value will be calculated depending upon the test concerned, the type of test we are using. So actually there are 3 different formulas for p-value, and you remember the p-value is nothing but a kind of level of significance. Let us come back to the problem which is given over there. First of all, we are going to calculate the things which are actually given with the given data. I'm going to calculate the z, and then the way by which I have shown you to reject or accept the null hypothesis in the previous classes, that approach I'm going to avoid for today. I'm going to draw my conclusion on the basis of the p-value approach, because if you are learning statistics and if I do not discuss p-value, then your statistical notion, your statistical ideas, your hypothesis testing rules, that discussion will remain incomplete. So p-value is actually, if you go for any massive open online courses, or if you do any courses in IITs or in any other reputed institutes, all in each of these cases, they actually try to test the null hypothesis on the basis of the p-value. The previous approach sometimes they use, but it is the previous approach that I have made is not actually general. The general approach is the p-value approach. In the question, it is given a candidate for election made a speech in city, but not in city B. Now, a sample of 500 voters from city A showed that 59.6% of the voters were in favor of him. And whereas a sample of 300 voters from city B showed that 50% of voters favored him. So in one city, the candidate has made a speech, but in another city, he has not made any speech. Now, here the basic objective of the problem is to check whether this speech made by the candidate, is it actually affecting his winning or losing the election. That is the important thing. Okay, so it has been observed that by doing some kind of survey, which is called the exit poll survey, that 500 voters from city A, out of these 500 voters of city A, 59.6% are percent of voters are influenced by him. This percentage of people has been chosen from city A, whereas in city B he has forgotten, or for some reason he couldn't give a speech or he couldn't get a chance. Despite this particular fact, out of 300 voters from city B, only 50% are favored of him. That is exit poll is showing. So we want to test whether the proportion of voters in city A and proportion of voters in city B, proportion of voters affected by speech and proportion of voters in city B not affected by speech. I want to test whether there is any kind of significant difference between them or not. So that's why it is a problem of test of difference of proportion of population. So I'm going to start it. The first portion of the problem, I'm moving very fast. I'm going to do very fast. When it comes to the section of p-value, then I'm going to slow my approach, and I'm going to slower my approach, and then I'm going to explain what is happening over there. Okay, so first part is actually known to us. We can quickly do it. So how to start the problem, because there is a kind of style by which you have to write the problem. First of all, solution. First of all, you will write that suppose capital P1 is the proportion of voters in city A where speech is made, and P2 is the proportion of voters in city B where speech is not made. We set up our null hypothesis as follows. We set up our null hypothesis as H naught, there is no significant difference between the two proportions, between P1 and P2. And number two, that is the alternative hypothesis, is that P1 is not equal to P2. When I say that there is no significant difference between P1 and P2, we actually mean that P1 and P2 are same. Under this null hypothesis, your Z is actually given by the following formula. You already know, it is written in the first page. It is small p1 minus small p2, but you see the second part is this p1 minus p2. This is the actual formula, but since in the null hypothesis we already assume that p1 minus p2 is 0, so that part will not be there, and therefore our formula reduces to p cap q cap 1 by n1 plus 1 by n2 under square root sign. Now look at the problem and try to identify what sort of information are provided over there. So let us try to identify those information first of all. The sample size, the first, if I consider the CTA sample is the first sample, this is my N1. And this is my sample proportion, which is P1. So I'm going to write it over there. My N1 is 500. My sample proportion is 59.6%, or I can write it as 0.596. This is for CTA. My sample size N2 is 300. This is my N2, and my sample proportion for CTB is 50%. So we write N2 to be 300 and P2 to be 50%, which is 0.50, which is CTB. Okay. Now you can easily put the value of P1 in the formula, which is 0.596, and you can put the value in P2, which is 0.50, and P cap can be calculated by the formula x1 plus x2 by n1 plus n2, but the knowledge of x1 and x2 are not known. Rather, we have small p1 and small p2. So in place of x1, you can write it as n1 p1, n2 p2, and this can be written as n1 plus n2, because we know that x1 by n1 is equal to p1 and x2 by n2 is equal to p2. So by this you can calculate p cap, and you also know that q cap is given by 1 minus p cap. So, and sample sizes are also known. So I'm going to calculate the Z value for this particular problem. So you just wait, let me calculate the Z value, and then I'm going to write the values one after another. Just wait, I'm doing the calculation. From my calculation, if I'm not wrong, the P cap is coming out as 0.56. And Q cap is coming out as 0.44. So I can put these values over here, 0.56 into 0.44, 1 by 500 plus 1 by 300 under square root sign. Let me calculate the Z value. it is coming as 2.648 approximately. If I'm not wrong in doing my calculation, it is coming as 2.648. Now, by my previous rule, you already know that we can draw the conclusion very easily because it is given that use 5% level of significance. We can instantly say that according to the previous strategy, that means without calculating the p-value, let us check what is my conclusion in this case. Without p-value approach. Without p-value approach. Since alpha is set at 0.05 and we know that further analysis is required, as mod z is less than 3, we find that the calculated value of z, which is z naught, which is 2.648, is greater than 1.96, which implies h naught is rejected at 5% level of significance. Which means the voters of city A and city B are affected by the speech of the candidate. In other words, before election, if you are a candidate, you have to go to make your speech in each and every city so that you can increase your chance of winning. This is my old, the way by which we have done it. This is my old approach. Now I'm going to talk about the new approach that is called the p-value approach. And since my session is about to end, so I'm going to explain the p-value approach for the given problem in the next session. I have opened the chat box. Chat box is now open. Those who have not put their attendance, please do so very quickly so that I can save the chat. And I'm going to explain the this particular example in once again there, but the conclusion will be drawn from the p-value approach. The approach which I have shown over here is the old approach. There comes a question whether this 2.648 and 1.96 is actually they are very separate, too much separated. But if you observe 2.64 and 2.58, these two values are not too separated. They are kind of close to one another. So I'm going to explain these issues in the next session. And those who have not got the question, please take a screenshot of this.